3.9 day 2, and then this packet is done. Okay, so at the top where it says your direction, it says for each of the following, find the vertex and then your x-intercepts. Understand now there are some that don't have x-intercepts. You're going to be able to choose whatever method you want to figure out what your x-intercepts are. So the first thing is, how do we find our vertex? So if I want you to graph these, none of these are in vertex form. These are what we call standard form. So that's kind of our first thing. So we want to put this in the vertex form. Grab a new pen. So to put this into vertex form, this is the whole, let me do it over here so we have some space. That you're going to take that x squared minus a 6x, make a perfect square out of that, and then adjust the 27 on the back end. All right, this hopefully we're pretty good at. We're going to take that negative split 6, we're going to split it into 2. That gives us 3. So we would have 3 times 3, which is a 9. So we would want to add 9 on the inside. Tells us we want to subtract 9 on the backside. So our vertex form then should be, this would have been x minus a 3 times an x minus a 3, and then a negative 27 minus a, man, that's a big number. Yeah, negative 36. What were we thinking by making this xy plane here? That's our vertex, 3 and then negative 36. All right, so as best you can, draw that in. So here's 3, and then just put way down here, we'll say that's 3 negative 36. All right, we'll extend this, and we'll make a big jump to make that a negative 36. Now what you have to understand is when you're asked to find the x-intercepts are your solutions. So now any of our methods are available to us. We can either graph, or we can either factor it if it factors. You can do the quadratic formula if you love the quadratic formula, because that will always work. Or you can do the completing of the square and then doing our square root method. Most of us, when I gave you that option, and this was smart of us, if this factored, we would want to factor this because that's the easiest and the quickest route to be able to solve this. This one does factor. So if I look for two numbers that multiply to be a negative 27, and you could probably come up with the two numbers that give you 27. I think there's only one combination that does that, other than 1 in itself. And then we also need to add up to be a negative 6. Then we can factor this pretty quickly. So that we would get x, and then the two numbers would be a negative 9 and a positive 3. If we multiply them together, negative 27. If we add them together, you're going to get a negative 6. So then we talked about, we set these equal to a 0, figure out what x values make each of those factor in itself into a 0. So for this factor, it's got to be a positive 9. So that's one of our solutions, slash x-intercepts. So go to your graph, and we can now put a dot on a positive 9 on the x-axis. The other factor has an x-intercept of x equals a negative 3, because that's what's going to make that one a 0. So we come over here to our graph, negative 3. So if our vertex was way down here, and then we know we have to open upwards and go through these 2 points, that's what our graph is going to look like. That we sort of have been doing. So what we now want to understand is the last part of this. It's going to be down here. We'll get to it. So we'll get to these down here in a second when we describe the nature of the roots. That's all we're going to do for this. All right. Actually, let's do them now. So go underneath here, number 1. So if I ask you now, number 1, what is the nature of our x-intercepts? What that really just means is the type. So the first thing I would expect you to identify tomorrow when we do our little quiz is how many do we have? Because we now know we can get 0 reals, we could get 1 real, we could get 2 reals, or we can get 2 imaginary. So notice, we're crossing the x-axis 2 times. So we get 2 real solutions. And I also would want you to identify, are they rational numbers or irrational numbers? So if we look at the 2 numbers we got, and we can look right here, There are no radicals involved in that. Those are nice numbers. So we get two real numbers, and those real numbers are rational numbers. Okay? That's what it means to describe the nature or type of solutions that we are talking about. We get two of them. They're real numbers and they're rational numbers. All right? Okay, next one. Let's go ahead, put this into vertex form. So again, you're going to get x squared minus 6x, and then plus a 7. Notice this is the one that we just did, right? X squared minus a 6x we just did over here. So we should know to make that a perfect square, you're going to need to add 9. And on the back end, you're going to have to subtract 9. So in vertex form, we have that x minus a 3 squared again, and then a minus a 2 on the backside. So our vertex should be 3, and then, oops, don't put it right there. Should be 3 negative 2. Right, so that's our vertex. And then you were told that you have to figure out what our x-intercepts are. So what we again want to do is look at this here, see if this factors, because if this factors, that's probably your best bet. All right, Cam's shaking his head no. Okay, Ahmed is, I'm shaking my head no. That is not going to factor. So since that is not going to factor, the only way we're going to be able to find these x-intercepts is either of the other two options, the quadratic formula or the whole square root method. All right, both of them are viable, both of them would work. I think most people do the quadratic formula, having seen your quiz from last week when I graded that. So that's what we're going to do. We're going to go through this with the quadratic formula. I might recommend doing this below. So let's go down here to number 2. Let's do it below. So, and then this will also give us the nature of our roots. So we have x squared minus 6x plus a 7. So let's do it down here where we have some room to operate. So x would equal the opposite of b. Our b has to be this negative 6. So that's going to be a positive 6. Over b squared, or square root of b squared. And then minus 4 times a, which is this 1 here. 1 in front of the x squared. And then multiplied by c, where c is a positive 7. And all divided by 2 times a is 1. All right, so we're going to get 6 plus minus the square root. Negative 6 squared is 36. Actually, go ahead and finish that off. I'm going to pull up my calculator. I'm realizing I want to have the calculator out so I can show you something. So finish that off. We should be able to finish that, I would hope, at this point, the end of the chapter. So finish that quadratic formula problem. And then I'll do it in a second and then check and see if you got it right. So here we go. All right. So we should go minus 28. The denominator would have been a 2. So inside here, you get 6 plus or a minus an 8, all divided by 2. I'm going to simplify that root 8 with a root 4 and a root 2. So we should get 6 plus or minus a 2 root 2 divided by 2. If you stop there, not necessarily wrong. The quiz that I gave you last week, I expected you to simplify this. So the 6, the 2, and the 2 here are all divisible by a 2. So divide each of those by a 2, and we would get 3 plus or minus a 1 root 2, and then all over a 1. And since our denominator is a 1, we don't really need to show that. Okay? So that's what we get. So if I now want you to graph this, okay, for the sake of this problem, we need to sort of know, these are our two x-intercepts. We need to know what those numbers actually are. So that's where the calculator would come in. So I'm going to do one of them is 3 plus a root 2. So I do 3 plus a square root of 2, and that's about 4.4. So we're going to go to our graph, and where you think 4.4 is at, put a dot. So it should be right around here.
So on the quiz, if we got like an irrational number like this, would you want us to put it in the calculator?
If I'm asking you, if you had to graph it, then that's why I would want you to put it in the calculator. Because if I ask you to graph this number right now, I mean, unless you're really, really good, do we really know what this number really even means on a number line? No. So for the sake of graphing, we would want to throw that into the calculator for that purpose, so that we could then actually plot that approximate point on the x-intercepts or x-axis. Okay. So that's why I'm doing that. And then the next one, we would do it as if it's a 3 minus that root 2. And we should get a little over 1.5. So we come up here and then plot our black. That hopefully makes sense, because remember our axis of symmetry, do those points look to be equidistant from the axis of symmetry? Yeah, they should be. Jar, parabola, in. So if we just had the graph, this one here goes through nice whole numbers. We could look at the graph and say that those are real and rational. This one, these are definitely two solutions. We cross the x-axis 2 times, because ultimately what we want to know is what's the nature of our x-intercept. So they're 2 real numbers, like we can actually plot those on a number line. But notice how we have this square root that we can't simplify. That tells us that these are irrational solutions. So they're 2 real numbers, but they are irrational numbers. Okay, and that will always happen if we get a positive number under here that's not a nice perfect square. Okay. Okay, last one of these real quick. So let's come on up. One more time, practicing completing our square, putting this in the vertex form. So we get our x squared minus a 6x again with a plus 10. So this is the 3rd time in a row now. So we should know we're going to add 9 here, subtract 9 there. So our function for this one is x minus 3 quantity squared, and then 10 minus 9 is a positive 1. So our vertex should be here at 3, 1. Now, to find our x-intercepts, we're again hoping this factors. So we would look at this equation, cross our fingers, and say, all right, maybe that will factor for us. That should not take long at all. In terms of 2 numbers that multiply to be a positive 10 and somehow add up to be a negative 6, all right, there's really no numbers even close to that combination. So this doesn't factor either, okay? So let's come down here for number 3. And let's do this one. So this was x squared minus 6x plus a 10. All right, so if we do our quadratic formula again, the opposite of b is again a 6. And then you're going to have a negative 6 squared minus 4 times a times c. Divide by twice a is our 1. Start cleaning all that up. So we're going to get our 6 plus minus a 36. This is the negative 6 squared. And then the negative 4 and 1 make a negative 4, but then that negative 4 gets multiplied by a 10, so this should give us a negative 40. And then this is all over 2. Okay? So if we come into here, we get 6 plus or minus negative 4, all divided by a 2. And this is now what we've been spending the last 2 days on. If we get the square root of a negative 4, let's clean this up first. So let's go ahead and see if we remember how to simplify this. This would have been our homework last night or 2 nights ago. If I wanted you to simplify that, this is when we do a 4 times a negative 1. We know the square root of 4 is a 2. And we also now hopefully know that the square root of a negative 1, so absolutely know this tomorrow, that's what the letter I stands for. So this guy completely simplified. It's pretty much the same as this one over here, right? They can all be divided by a 2. Would give 3 plus or minus a 1i over a 1. What this means is we now have 2, and as soon as you start talking about these imaginary numbers, that means you don't have any real solutions. So there are no real solutions. What we simply have are 2 imaginary roots or 2 imaginary solutions, whatever word we want to use. Think about what that now looks like in terms of a graph, right? So let's go back to this graph. Notice how this crossed the x-axis once, twice. So there's 2 solutions. This one crossed once, twice. There's 2 solutions. If we have 0 real solutions, this graph should not cross the x-axis at all. So if we go to, here's our x-axis, and here's how we would know that, right? So let's revisit our A here. See how there's a positive 1? Doesn't that tell us our parabola opens upwards if we have a positive coefficient? So if I now, because we really don't know our x-intercepts, we don't have them, so just sketch in, we won't go too crazy with how we make this accurate. If that opens upwards, which it does because of the coefficient being positive there, does that ever cross the x-axis? No, so that's why there's no solutions to that problem. The quadratic formula proves that out by giving us this negative number. All right, the other thing, because I'm in the middle of writing the quiz now, recall what the number underneath here, in this case it was an 8, in this case it was a negative 4. Remember, that's called our discriminant. Okay, and we're going to do that here in a minute anyway. All right, that's our discriminant. All right, so moving along. If we have time, we're going to come back to these. This is what we spent all day yesterday doing, and you certainly need to know how to do these for the quiz tomorrow. But to make sure that we're doing the stuff that we haven't done in a few days, jump down to 10, 11, and 12. And again, if we get 10, 11, and 12 done, we'll revisit 4 through 9 just to make sure we're cleared on all of that. But I want you to go to 10, 11, and 12 right now. Because understand this set of directions. All I want you to do is describe the roots of the following quadratic equations. So you have 2 options to solve these. One option, if I can get my pen to work. So option number 1 is to, come on. So I just put a new battery in one of them. There, this one's working good. Is to solve the equation. And you can do that either by factoring, quadratic formula, or the perfect square method. Or simply find the value of the discriminant. So if all I want to know is what kind of solutions we get, which is all this is, describe the roots, we don't necessarily know what the solutions are. We don't need to know that. We just need to know what type they are. So what I mean by that, so let's revisit this, because this is now what we did a few days ago. And this is definitely on the quiz tomorrow. All the discriminant is when we do the quadratic formula, the discriminant is just this part of it, the square root element of the quadratic formula. So if we do that here, and we just do b squared minus 4ac, and just worry about that, let's plug in using this equation. So b, notice how there's a negative 1 in front of the x. So the b has to be a negative 1. So I would just do a negative 1 squared minus 4. Our a is a 2. And then our c has to be this 4. So if I ask you for the discriminant, that's the only part you're going to be doing. So when we now do this, I'm going to get 1. And then let's multiply all of this out. So negative 1 squared is a 1. A negative 4 times 2 is a negative 8. That negative 8 gets multiplied by a positive 4. So that should be a negative 32. So what we get underneath our radical is a negative 31. So what we then have to understand, when we get that negative number underneath, and there's different ways I could ask it, there are 0 real solutions. There are none. If we were to graph this equation, you're not going to cross the x-axis ever. But what that does tell us is we are dealing with 2 imaginary solutions. Okay, that's what we're talking about when I ask you to describe the types of roots that we get. Yeah, Cam?
That last thing you just said answered my question. So
Okay.
we only need to look at the discriminant when it says describe the roots.
Correct. You can do all the work if you wanted. So if you wanted to go through all the work, there's nothing wrong with that. It's a safe bet. So I could put the plus minus here. The opposite of B would have been a 1. And then divide this all by 2A, 2 times 2. You could go through all of this. What your answer would have looked like, you were going to get 1 plus or a minus. This would have all been over a 4, 1 plus or a minus, this all over a 4. So you can do all that. There's nothing wrong with it. But what we're just looking for in the nature of the roots, even if you did all of the work, doesn't it show out that we're getting this negative number underneath, which is then telling us that we get an imaginary? So you could just do all the work if you really wanted to, but you don't need to. Okay. All right, so letter B, same exact thing. If I just want to know the nature of the roots, all we're going to worry about is the discriminant. B squared minus 4AC. B is 12, so that's our B. So 144. So 12 squared is 144. Minus 4 times A times C. Ooh, I might need a little help with that one. 3672. Oh, never mind. I know what it is. All right, so we now multiply all these together. Negative 4 times 4 is a negative 16. And then a negative 16 times 9 would be a negative 144. So our discriminant is 0. You remember what that meant?
That there's like 0 real or like solutions?
Not quite. Let's go ahead and do it then. Let me, so you don't have to change yours necessarily, it's up to you. But let's say we did the quadratic formula, since I'm sure we all love the quadratic formula at this point. If we did it in its entirety, so the opposite of B would be a negative 12 here. And then on the bottom, I'd have 2 times A, and the A is a 4. So now let's see how this plays out. We know we're going to get a 0 under here, and then we're going to get an 8 right there. So what that means is, don't I really just have a negative 12 plus or minus a 0 over an 8? Well, if I did a negative 12 plus 0 and divided that by 8, and I do a negative 12 minus 0 and divided it by 8, won't those give us the exact same answer? Aren't both of those going to give us a negative 12 over 8, a negative 12 over 8? So we do get an answer, right? But aren't they the same? So what that means is we really get one solution. So if we get a 0 for our discriminant, what that means is we do get a real solution. We get one real solution. And it's a rational solution because 0 is a nice number. We don't have that radical in our problem. All right. So definitely know that. I'm going to test you on that tomorrow. If our discriminant is a 0, that means we just have one solution only. We only touch the x-axis one time. Okay. All right, and the last one of these guys, same thing. And we'll do our B is 7 squared, and then minus 4 times A times C. And again, if you want to do the whole quadratic formula, do it. Maybe that's safer for some people. Okay, that's fine. And then we get 49 minus 12. So our discriminant has a value of 37. All right, so we get real solutions, right? As long as we don't get the I underneath there, a negative number underneath there, we get some real solutions. We get 2 real solutions. And since this is now an irrational number, can we take the square root of a 37? No, so that's irrational. That means our two real solutions are irrational solutions. All right. All right. So know that, have these next to you. I mean, you can have your notes next to you tomorrow when you're doing these. I am definitely going to be testing you. If your discriminant saying root negative 31, what does that mean? If I just ask if my discriminant is a 37, what does that mean? And you're not necessarily doing any work. Okay, so keep those next to you so that we're clear on everything. Let's do one or two of these, just make sure we're clear, we're fresh on all of this. Probably the hardest one is number 9. So let's do number 9 first. We'll work in reverse order of degree of difficulty with our last 5 minutes. We wrapped up class yesterday with these, where I had an I to the first, an I squared, an I cubed, and an I to the fourth. They all meant a little bit different things. So for this first one, there's not much we can do with the I, so that doesn't get changed. But then if you remember, I squared was a -1, right? Plus, if you remember what I cubed was, that's great. If you don't, we could write it as an I squared times the other. Hold on a minute. We can write it as an I squared times I. And then the same thing with that I to the fourth. If you don't remember what it was yesterday, we could write it as I squared times I squared. So 2I we can't do anything with. But this we can definitely change to be a -3. 3 times a -1 is a -3. And then we again get to I squared. I squared is a -1. So -1 times 4 would give me a -4, and then we'd still have this single I hanging out with that -4. We go to the final term, that 5. So here's 5. So I'm going to rewrite that. But then think about what we now have. I squared means I'm going to multiply by a -1. And then I have another I squared. So that's another -1. So we have 2I -3 minus 4I. And then think about what this would give us. A negative times a negative is positive. You really just have 5 times a 1. So this should end up being a +5. Add your like terms. So we have i's that are like terms. So you're going to do a +2 and a -4. So -2i. And then we also have a -3, +5, which is 2. Now, just understand, I wouldn't mark this wrong again if it's one of the ones where I have you fill in the paper on the computer or you use your mouse to write. I'm going to accept this. But when it's multiple choice, general form for any imaginary number, the real number goes first, the imaginary number goes second. So I would probably rewrite this real quick if it was multiple choice, and I would have put this guy first. So the +2 would go first. And then that -2i goes second. So it would actually look like this. So just make sure we understand that these two guys are equivalent. This would probably be how it looks on the computer when you're picking out the multiple choice answer. Okay. That really is a pretty good problem to review what we did yesterday and what you're going to see tomorrow. All right. Last thing real quick, because we got less than 3 minutes. So, like I did last week before the quiz, for those who are kind of teetering in between some grades, if you want a little boost to your grade, the homework on 3.9 here, I'm afraid to pull up the homework. Let me pull it up. We have a minute. So I can tell you the exact page number. But what I'm going to do, I'll give you an opportunity for some extra credit with this one. It'll be a nice little review. Make sure that we're kind of squared away a little bit on that quiz. So let me go to homework packet. if you want a little extra credit, then the homework for tomorrow is page 27. Okay, so in your homework packet, you're going to factor these, get a little practice factoring. You're going to use the quadratic formula to solve this. You're going to find the value of the discriminant, and then you're going to state the nature of those solutions, stuff that we just did. So what was page 27? Do 1 through whatever that was, 12. All right, for some extra credit. Okay, and then get that uploaded by tonight. It'll give you something to look at. If you have any questions, see me tomorrow morning. See Mr. Kubowitz tomorrow morning during second period, and we'll try to get you all squared away on all. Okay?
Mr. Farah,
Yes.
will you be recording today? It will be on camera.
It is recorded already, so I'll stop it right now. Yeah, and it should be good.
All right.
Yeah, it should be uploaded tonight.
All right. Thank you.
Okay. All right, with that, we'll see you guys. Have a good day. See you tomorrow. At least I think I was recording it. There it is. Yeah, we got some spinning going.